Mr. Crispin here once again, and welcome to my workshop. In today's video I'm going to be doing some internal grinding on the lathe, and I'm also going to be doing some slightly unorthodox work holding, so you will shortly see some of the pieces I've got to hold in the lathe to do this grinding. But before I get into that, I want to start the year on a serious note and invite you to join in my caption competition. Now, no, I did not put it up there by myself, but as you may have guessed, I did have to get it down there by myself, so I invite you to leave your comments in the description and there will be a prize for the best caption. Without further ado, let's get on with some machining. The workpieces for today's video can be seen here: 4-jaw chuck, faceplate, 3-jaw chuck. I recently reground the spindle nose of my lathe, and I did so because its condition was somewhat questionable. The condition of the mating faces on these pieces of tooling are also in somewhat questionable condition, and so while I've got the tool post grinder set up, I'm going to attempt to regrind them. Now, this is going to be a bit of a game of chess, because obviously somehow I have to hold these pieces to regrind them, but equally I don't want to install them on the lathe as they are, because their surfaces with dings and high spots may make impressions into the freshly ground surfaces I've just created on the spindle nose. So the unlocking piece in this game of chess is going to be this. This is a brand new backplate, which I'll be fitting a collet chuck to at some point, but as it stands, the bore and face are in pristine condition. So however I go about this, this is the starting piece. This will be in the lathe headstock first. My initial plan was to take this and put some tapped holes into it, and then with this in the lathe headstock I would bolt this to it. So you would have this here, I would bolt this to it somehow, and then that would allow me to grind the internal bore and the face. Once I had ground this piece, I could then use this to hold the 4-jaw chuck body and the 3-jaw chuck backplate by clamping it onto here and then working on the front. However, that involves quite a lot of drilling holes, making clamps, tapping things, finding blocks. So sometime during last November I was fortunate to have had a vision where a different idea came to me, and this is the idea I'm actually going to go with. What I'm going to do is put this in the lathe headstock, and I'm then going to use the 4-jaw chuck to do a bit of reverse psychology. I'm going to take the 4-jaw chuck, bearing in mind I want to grind this side, and I'm going to clamp the 4-jaw chuck to the back plate and then regrind it. So I haven't attempted anything like that before, but I can't see why it won't work. So first of all, I will be clamping the 4-jaw chuck to the back plate and regrinding it. Once I've done that, I then have a 4-jaw chuck that can be installed on the lathe, because I will have reground this, so that will then go onto the headstock, and once that is on the headstock I can then hold both the faceplate and the 3-jaw chuck back plate in it while I regrind them. So this is going to start the ball rolling. This will allow me to do the rest, and the idea of this whole thing is I don't have to make any clamps, do any drilling and tapping, and hopefully makes the process a bit more efficient. Stand by My plan has been foiled slightly. Let me show you from this side. What I had been hoping is that I would get face-to-face contact down here, but because there is a change in diameter on this OD and because of the depth of these steps, actually the jaw can't quite reach. Now there's potential here for trouble, because if I show you how the chock has landed just as I've placed it on here, you can see that in some places the jaw has come all the way up, has made the face, and it must just be gripping on that tiny little bit. So these are the kind of scenarios which you really have to watch out for, because if you were to just proceed and push this face all the way up, all you'd actually be hanging on by is the contact on this little band of diameter here. And you know, any sudden jolt in the machining, if the forces were enough to throw it back a touch, suddenly it's on a smaller diameter and the whole thing will come loose. So what I'm going to do is find out what size packer to use in here to make sure that I'm definitely on this section in diameter and not the larger one, and I will then proceed with caution, making sure everything's nice and solid before I turn anything on. But be very careful in these scenarios where you could inadvertently end up holding on a small ridge that with any shock could free the workpiece. I have changed my mind. Were I set up for turning, I could of course solve this problem by turning the OD. I decided not to go down that route because I'm not set up for turning, but I've decided I really don't like the idea of using packers with this thing being so big and on such a small hold. So what I'm going to do is just take the time to grind that diameter back so that I can get the proper grip. I think packers would work, but seeing as I'm not in a hurry here, I might as well take the time and try and get the hold as good as possible, because one thing is for certain, I do not want this coming off. Not only is it a bit of a hazard, but it would also destroy the tool post grinder because the spindle's going to be in here. So let me whip this off and without dropping it, and see if I can grind that step out, or at least back far enough. Right. No, I don't have a crane. Right, don't worry about the aesthetics, by the way. When I come to fit the collet chock, I will be remachining the whole diameter anyway. But that now gives me a nice band I can hold on, and with that said, it is time for attempt number 2 of installing the chock. It can now be observed that the holding pattern is a lot better. Right, having got it roughly aligned with the plunger clock, I've now got a 2 micron indicator here, and positioned for your convenience, I'm using it to give me a reading of this axial runout. Now I'm using a slip gauge just because there's so many pitted areas, and you saw me stoning it at the beginning. That was to take any high spots off, just so this check is actually of some relevance. Now basically, for starters, I'm going to see if I can give it a clonk. So that is the highest jaw. Beauty of using the slip gauge as well is I can hit the workpiece without it shocking the indicator. Oops. That's the high one there. Now if they all end up hard against the back plate, giving it a clunk won't do much. After about half an hour of messing around, I have done my final tightenings of the jaws, so I'm happy to go for it at this. Let's have an overview of the alignments. First of all, axial alignment as measured on the back face. We're using the same slip gauge technique because of the undulations. So I'm going to zero, well, let's say that's 0. Okay. And rather than trying to sweep the chuck, I've just picked 4 spots which I've stoned any high spots off. So we were -2 on the first one, a -10. -10. And -6. So that is pretty much in line, that back face. So when I do the grinding on this side, this face is going to be parallel to it, and as a result, when I'm actually using the chuck and this face is aligned to the back register, this face should be square. So if you didn't catch that, basically it means it's okay to carry on. Now, what about radial runout? Radial runout as measured on the chuck body, we are at -20-ish microns on that side. -10. -20. And -30, so it's within 20 microns. That is the chuck body and face, and to be honest, as I've said earlier, that is really what I'm interested in, because this side is going to be reground. Just so I know what to expect when I start grinding, however, I will check this side, and here it's looking like a range of about 20 microns. Now, the radial runout is rather harder to check here because there's that many undulations in the bore that you just can't get a good reading, and obviously it's no good holding a slip gauge in there. But what I can do is show you something I made earlier. This middle bit's just a handle. This is a gauge, and it's a carbon copy I've made of the chuck backplate, the brand new one. So this is an exact match of that chuck backplate, and it's what I'm going to use as the bluing master to get the fit right. But also I can use it just as a sanity check here. So if I turn that in, let's have a look at how this reads, because the OD was turned in the same setting as you know, the front geometry. Sweeping the OD, it's within about 10 microns.
Is Sir ready for a cup of tea?
Thank you, Jefferson. Yes, that's a nice idea.
Would you like it in your regular mug, or would you like it in a cup and saucer with a teapot?
No, just in my normal mug's fine, thank you. Right, where was I? Ah yes, setting up for grinding. Okay, so this is all coming to bits, and out comes the master. Right, first of all I'm going to scratch onto the inner face and then back off a little. Let's back off 4 thou and just do a sanity check. Also, another good sanity check is get hold of the thing and make sure it can't shake free. Right, let's go somewhere like that, I think. Okay, so that has done something. Surface finish is satisfactory. Right, that would probably be just enough. So in light of the fact that I don't want to take too much off and have to, you know, take loads off the face, I'm going to now move on to the face, and if I happen to come back to the bore later on, then I will do, but for now let's move over to the face. That's a start of a 10. Let's see how my gauge interacts with this. Right, the face is what needs grinding, and that goes in as a little side to side play, so that means the taper is loose and I need to take quite a bit more off here. Right, I'm about there now. I wasn't getting anywhere fast, so I swapped out to a 40 grit wheel, which has helped a bit. It was mentioned in an earlier video that viewers would like some dimensions, so they know how much material has actually come out. Well, the bore is anyone's guess, because although I could tell you how much actually moved to carriage, when you're touching on, you're not really touching on the full surface, so the bore, as I say, is anyone's guess. The face, however, I have been keeping tabs on. I've got a particular spot that I've marked down here, and so off the face I have taken 0.17 millimeters, which I guess is around 7 thou. So with no coolant and these small wheels, that's actually quite a lot of grinding. Oh, hang on, sorry, one moment. Thank you, Jefferson.
Sorry to trouble you again, sir. I've noticed just lately that your books of Sempervirens are a little bit lacklustre.
Really? Well, I'm feeling okay.
That's books of Sempervirens.
Yes.
That's Latin for box hedging, sir.
I know that, yes. I know that. I'm going to take a look at it tomorrow.
Oh, as you are, sir. Oh, sir, would you be in for your 5 o'clock showing?
Yes, thank you, Jefferson.
Very good, sir.
Right, back to this, and basically, according to this gauge, I'm now there. I could blue it up and do that for fun, but to be honest, I think that's that. So what I'm going to do is put its pegs back in, and I will now use this as the work holding arrangement for the following 2 pieces. Clearly this needs a bit of a clean. I haven't bothered protecting any of the apertures here because this chuck is due a full strip down anyway. I haven't had this to bits since I got hold of it, and clearly it's due a bit of a service, so I haven't bothered protecting it for that reason. Right, on with the other pieces. Holding these 2 pieces has turned out not to be straightforward. First of all, the 3-jaw chuck backplate. Now, my mind's eye had it that this was a backplate with a fairly shallow boss on the back. However, actually, as you can see, it's a pretty deep boss. Now, I was planning at coming at this with the 4-jaw external jaws from the back, but obviously with this long boss I can't reach. So what I've had to do is rethink, and basically I'm going to have to hold it back here. I did consider other options like mounting the whole chuck body and then holding the whole chuck, and I've decided to stick with the idea of holding it with the external jaws just further back. This boss, however, is very thin and a bit springy, so what I have done is I've taken some bits from the standard milling clamp set and I've made a cross brace. This is a cross brace using studs, long nuts and then aluminium rivet heads cut off to form a good contact point within the concave surface. For that lower one I couldn't fit into rivet heads, so I have done that slightly differently, but basically when I now clamp across here and here I will be clamping something solid. So that's that. The faceplate has also not been easy, and despite my earlier hopes I have not managed to avoid the curse of the block. By the curse of the block I mean having to find blocks that are the right thickness with the right hole spacings, etc. This turned out to be incompatible with the setup I have. The 4-jaw chuck is big enough to grip this on the outside, which is what I was planning, but then the jaws come into collision with other things. So I have mounted 4 blocks on here, and then I can use the external jaws to grip it within the swing. I have taken care to get the blocks parallel so that the jaw contact pattern is nice, and I've also taken some care to get them reasonably square. And the reverse of this can be seen here. I've just had to find whatever clamps and nuts I can to do the job. So I will now be grinding these 2 items in much the same way as I ground the first. I have now reached the appropriate gauge fit and size on this 3-jaw chuck backplate, but believe me, it has taken some doing. Not only was this badly dinged, but it was also wallowed out, and so to regain a surface in here I have subsequently had to grind 0.49 of a millimetre off this back face. Now these little wheels were just not going to be up to it. I was going to run out. Every time you redress them you of course encroach on the recess and it becomes shallower, so I had to be brave and swap for a 3-inch wheel. 3-inch wheel on a 3/8 spindle seems a little nerve-wracking to me, but it did fine, and it allowed me to do what I was trying to do. Thankfully, this is the worst backplate out of all of them in terms of the damage that was in it. I'm hoping that the faceplate is more straightforward and that it requires a lot less grinding off. So the tool post grinder needs a break. Sherrier clock is fast approaching, so although I was going to try and do all 3 in one video, I'm going to draw a line under it here for today. I will pick up next time with the grinding of the faceplate, and then I'm going to do a bit of a talk around the different wheels I've used, and I'm also going to do a bit of a talk around getting the right fit and what face to remove material off for different effects. And finally, I'll take a backplate or 2, offer them up to the spindle nose, and hopefully I'll be able to show how they're supposed to fit if I've done my bit right. So apart from that, I'll say thank you for watching. I hope you found this interesting, and see you on the next video.